Here we are discussing an interesting theorem from the chapter Functions. This theorem is based on invertible function. Here theorem number 2 is if f is a function defined from set A to set B which is invertible function, then we have to prove that f is 1, 1 and onto. We have to prove this function is 1, 1 and onto. And this is given that function f from A to B is invertible function. Okay, so let us see the proof here. Given function f is defined from set A to set B and f is invertible. So let us suppose that g is a function defined from set B to set A. Invertible means inverse of this function exists. So let g be a function defined from set B to set A. So therefore g operation f, this is identity function in set A, and f operation g is identity function in set B. First of all, we have to show that this function is 1, 1. So for showing that given function is 1, 1, if fx1 is equal to fx2 implies x1 is equal to x2, then function f becomes 1, 1 functions. So let us suppose that f of x1 is equal to f of x2. Applying function g both the sides, so g of fx is equal to fx1 is equal to g of fx2, and this is g of fx1 means g operation f of x1, and this is g operation f of x2, g operation f of x2, and g operation f is IAX, identity function in set A. So this is identity function of x1 is equal to identity function in set B of x2, and since these functions are identity functions, so image of the element is equal to the image itself. So this implies that x1 is equal to x2. So here we are getting fx1 is equal to fx2 implying x1 is equal to x2, and therefore f is 1, 1 function. F is 1, 1 function, correct? Now we have to show that this function is onto function. So let us suppose that y is any element in set B. So as f is invertible, so with respect to this f there must be a function, suppose g, whose pre-image in the domain is x. So we can write gy is equal to x, correct? Now applying function f both the sides, therefore f of gy is equal to f of x, or f of gy can be written as like this, f of g of y is equal to fx, or f of g is here, f of g is identity function in set B. So identity function in set B of y is equal to fx, or image of y will be y itself because this function is identity function. So y is equal to fx, or you can write fx is equal to y. It means for every element in B, we are getting a pre-image in set X such that fx is equal to y. That is, for every element of set B, there is x in set A. That is fx is equal to y. Therefore, this function f is onto function. So here we are proving that this function f, if this is invertible, then f is one function, and here we are proving that f is onto function. So this theorem has been proved here. Very interesting question, important questions. Hope you have understood it. So remain in touch with these videos, this channel. We have to see some more important questions, and hope you have subscribed this channel. If not, please get it subscribed and share this video with your friends also. And if you are enjoying these videos, you are getting benefits from it, your likes are most welcome. Wish you all the best.